Okay, we are going to hear a lesson this time on histograms. You probably can see that histograms should look familiar to you. Histograms are sort of it's a type of bar graph where you graph a whole collection of data. So each bar has sort of a collection of data in it, not individual data pieces, but a collection of data. There's two important kinds of histograms. One of them is just a regular frequency histogram, and what that does is it gives you a raw count. It tells you 5 people are in that category, or 10 restaurants are in that category, or whatever. So those are the frequency ones. And then the relative frequency gives you a percentage of whatever's in that category. So like right here, you can see that about 5% of all of the data would fall into that bar. Okay, so that's the difference. Frequency histogram gives you a raw count, and relative frequency histograms just give you a percentage of the data that fall into that category. The width of the bars, which is the distance from here to here, as you can see, that is known as, some books call it a bin, some books call it a class, some books call it a category size or a scale. Usually I'm going to refer to it as a class, but in this case, on the far left, that bin or class is 20, from 40 to 60 is 20. All right, some things you need to know about histograms. First of all, they are typically used for quantitative data, and that's probably a new word for you. Data falls into two types. There's quantitative and there's qualitative. Quantitative data is numerical data, anything that would make sense to either average or add up or something like that. So quantitative data would be things like age. It would make sense to find the average age. Or, let's see what else. Your weight, you can find the average weight, something like that, okay? Qualitative data is categorical data or word type data. So it would be like the type of house that you live in, or your phone number, or something like that. You wouldn't average those. That wouldn't make sense. So those are qualitative data or categorical data. But quantitative data are numbers, okay? You use histograms when you have large sets of data. If you have 50 pieces of data, you don't want to sit and make 50 individual bars. And so you're going to cluster that data to make a histogram. Really, really important that you choose the appropriate class for your histogram so that you don't have too many bars or too little bars, because it can really distort the data. And we will look at that more in class. I've got a little applet we're going to work through, but for now just know that. And then know that if a number falls exactly on a line between two bars, you're always going to put it in the upper bar, the bar above that line, instead of the bar below that line, and that probably will happen in your homework. Okay, then once you make histograms, there's some vocabulary that you need to be familiar with that we will use an awful lot. One of them is outliers, and we will get more detailed with outliers when we do other types of graphs. They're kind of hard to see when you do histograms, but for outliers, you're going to look for data that's way different than the rest. The formal definition is written in parentheses there. That won't really apply today, but we will be looking at that in future days, future lessons. The center is the median, or the middle, so that's where you would have all the numbers listed from smallest to largest, and you would find where the middle one is. Sometimes, you know, if there's two middles, you're going to have to average them. The spread is the smallest number to the biggest number, or the min to the max, and you would ignore the outlier. So if you have an outlier, you don't count it in the spread. And then the shape, there's some basic kinds of shape. Skewed left, skewed right. So skewed left means it's stacked to the left, or sorry, stacked to the right but trails off to the left. Skewed right would mean it trails off to the right. Symmetric is something that both halves are the same. Uniform is kind of a rectangular shape that would look something like this. And then bimodal is where there's two or more peaks, and we'll see some examples of these. And sometimes graphs can be more than one type. They can be both uniform and symmetric, or both bimodal and symmetric. So sometimes that does happen. And then the peak is, you're going to tell me where the highest bar is. You're not going to tell me how high it is, but you're going to tell me where it is. Where does it occur at? Which bar does it occur All right, so here's some examples of some histograms, and what I just want you to do is sort of be able to describe the shape for me. Excuse me. So on this first one, and you guys can maybe hit pause and try these on your own, is what I would suggest doing, and then coming back and checking your answers, okay? So you can hit pause right now if you need to, and then here we go. This first graph, the red one here in the upper left-hand corner, you can see that if I kind of do this, it does trail off to the right, so this one would be skewed right. This one you can see only has one peak to it, and you can definitely cut it in half. And this one is perfectly symmetrical. You need to know that very rarely is a graph perfectly something, okay? In this case, this graph is absolutely perfectly symmetrical. So I'm going to just say symmetric. If they're not perfectly symmetric, then you're going to say something like fairly symmetric, okay? This one you can see definitely has two peaks to it, if you kind of average that out. So because it has two peaks, it is bimodal. And then I would also say that it is not absolutely perfectly symmetrical, but if you go like this, that graph is pretty close to having both halves be the same. And so this is bimodal, and then I'm going to throw this word in here because it's not perfectly symmetric. But so I'm going to say this, it is fairly symmetric, okay? And you kind of need that word fairly unless it's absolutely perfectly symmetric, okay? This one is pretty close to a rectangular shape. It is not a perfect rectangular shape. So again, I'm going to say that this is close to uniform. I'm going to say fairly uniform. Or roughly uniform would be another word that you could use. All right, then here is an example of a histogram that is already done for you. And what we're going to look at is we're going to find the outliers, the center, the shape, all that good stuff about this particular histogram. Okay, so the numbers at the top tell you how many. You can see that this graph is about the percent of residents aged 65 and older in the different states of the United States, I assume. There are 50 pieces of data in here. The numbers at the top of each bar tell you how many states have percents of residents in that fall in that category. So like this bar right here, you can see that there is one state that has between 5 and 6% of their residents that are age 65 and older. Okay, it doesn't tell you what state it is, but it does tell you that. Okay, first of all, you're going to look for outliers, which are kind of hard to do on a histogram, but an outlier on a histogram will show up as a bar that is far away from the others. Like you can see right here, you have a little bit of a gap. It's not a huge gap, so I would say that this right here is not an outlier. It could be, but I would guess it's not. An outlier probably would be like if you had something way over here with this really large gap in there, then you would know that this is an outlier. That's not showing up on this graph. And you're going to kind of have to estimate outliers today. There's not necessarily going to be a perfectly right and a perfectly wrong answer. So I would say in this case there are none. Okay? The center is sometimes the ickiest part for people to find on histograms, but what you need to know is that there are 50 numbers in this set of data, 50 numbers in this set of data, and so kind of think about it like this. The numbers are going to go the smallest number, the second smallest number, and it doesn't have to be 1, 2, 3, but the numbers are going to be in order from smallest to largest. So first smallest, second smallest, third smallest, fourth smallest, fifth smallest, sixth, right? And there's going to be 25 numbers here, okay? And then there's going to be another 25 numbers here if we cut that in half. And that's perfectly symmetrical, 2 halves. And this right here is where your center or your median is going to be. So there's going to be 25 numbers here, then this will be the 26th number, 27th number, 28th number, da-da-da-da-da-da. This one will go up to 25. So you can see that your number here, your median, is going to be between the 25th and the 26th number. So I'm going to look at my bars and I'm going to see which bar does the 25th or 26th number fall into. Well, here's 1, 2, and 3 makes 5, and 1 makes 6, and 8 is 14, and 13 makes 27. So I know that the 25th and the 26th number both lie in this bar. I don't know what it is. I don't know the exact percentage. I know that it's somewhere between 12 and 13%. That's all I can tell you. Okay, so your center is between 12 and 13%. Okay, the shape, so you're going to kind of look at this, and if you sort of ignore this, I think you can see that this graph is pretty symmetric. Is it perfectly symmetric? Nope. So I'm going to say that it's roughly symmetric. Okay, then the peak. The peak is where the highest bar is. Again, I don't want to know how high the highest bar is. I can see that the highest bar is 14. That's not what I want to know. I want to know where it falls. And that highest bar falls right down here between 13 and 14%. And then the spread is the min to the max, and you ignore the outliers. So the smallest number up here would be a 5, and the biggest number up here would be an 18. So your spread is 5 to 18. If you said that this number right here was an outlier, then you would not include it, and you would say your spread is from 8 to 18. But we're not going to do that, okay? So we are going to say that our spread, I'm going to erase those so I don't confuse you, that your spread is 5 to 18. And just so you know, some books will report it as, they will literally write it like this, 5 to 18, and some books will subtract those two and print out and report it as 13%. So you do whatever you're comfortable with. I'm fine with either way. Okay, then we're going to do one more where we actually are going to put our data into classes or categories or bins, whatever you want to call them. So this is some data that was collected by 50 people that attended a training class, and their height is measured in inches, you can see. And so the first thing that we're going to do is we're going to take this data and we're going to make a frequency table. And when you make a frequency table, you're going to look, it's going to look something like this. So the first thing you have to do is figure out what you want your classes to be, how you're going to divide this up. And you can see you've got decimals in here. If you sort of scan through your list, you will see that there is numbers that are 65 or 65.5, I believe is the smallest number. 65, is there a 65 on there? And then you have a number that falls, a couple numbers that are 73 or above, okay? And you can see there's a lot of decimals in here and there's a lot of data. So what I would suggest doing on this one is going like this. You would go from 65 to 65.5 is probably what I would do, okay? And then you're going to go from 65.5 to 70. And technically, you guys, what you should be doing is this. You should be going 65 to less than 65.5. And then this one should be 65.5 to less than 70. I'm not going to write that out every time because I just don't want to take the time to do it. But that's technically what you're doing. Okay? And then the question becomes this. What if you have a piece of data that's exactly 65.5? Does it go into this bar right here, or does it go into this bar right here? And remember what we said in the beginning, if you have a number that falls exactly on the line, it should always go to the upper bar. So if you have a number that's exactly 65.5, it should fall into this bar right here instead of the lower one. Okay, so then what you're going to do is you're going to count. How many numbers do I have that are between 65 and 65.5? And again, if I have exactly 65.5, it does not go here, it goes here. Okay? And I do have an exactly 65.5, which is right there. Then I'm going to count numbers that are between 65, or sorry, I have one number that's 65. Then I'm going to count numbers that are between 65.5 and 70, and it can't be exactly 70. If it's exactly 70, it has to go here. Okay? So you're going to count. And what I would suggest you do is that you hit pause and you fill out the rest of this table right now. Okay, and we're going to get that far. So hit pause, fill out the rest of this table. Okay, then you should be able to come back here. This is what your frequency table should look like, or that first column of it. Then, to get this column right here, this is relative frequency, and all that is it's a percentage. So if you remember, there was 50 people, 50 pieces of data that were collected. And so what you're going to do is there's one person that fell into this category. So to get from here to here, all I do is I go 1 divided by 50, and that gives me a percent. In this category, there's 2 people, so I'm going to go 2 divided by 50, 2 out of 50, and that's going to give me 0.04, which is the percent of data that fall into that category. So relative frequency goes like that. Okay, so you should, again, hit pause. You can fill out the rest of the table, or you can look at here and just copy it if you kind of know what to do. Okay, I'm going to scroll down so that you can see the bottom of the table and check all your answers, and you can hit pause while you do that. Okay, then you are going to take that data that you had on the previous page, and you are going to make first of all, a frequency histogram. And I'm not going to go all the way through this, but I'm going to get you started on both a frequency histogram and a relative frequency histogram. So the first thing you need to know when you make any graph in math is that you first of all have to have a title. Okay, so my title up here, I'm going to say that it's height in inches of, oops, I forgot my N, inches of trainees. Okay. What goes along your x-axis is always going to be your classes or your bins. So I would label this like this: 65, 65.5, 66, 66.5, 67, 67.5, etc., etc., etc. Okay, you'd keep going. Okay. Your x-axis is height in inches. Okay. Then when you do histograms, your y-axis is always a count of how many people, or in this case people, fall into that category. So in this case, this is going to be frequency. Okay, and so you're going to count. There's 0 people, 1 people, 2, 3, like this. Okay, and then you're just going to make your bars. And so you're going to go, oh, how many people was there between 65 and 65.5? So you'll go back to your table and you'll go, oh, there was 1 person. I need to make that bar 1 high. So I go back here, I make the bar 1 high. It's nice to put that number at the top, although it's not required. How many fell between 65.5 and 66? There was 2 of them. So you go up here and you make the bar 2 high, like that. Okay, and you proceed. I think you guys can probably handle the rest of it. The only difference between that and then using this data to make a frequency histogram would be this. Title would be the same. Okay, your classes down here would be the same. All of that's the same. So you would start as, again, 65, 65.5, 66, 66.5, and you would still label this. Right? And I should probably have classes there. I should label this again as height in inches. Okay. And then if you do oh, sorry, you know what? I just messed this up, you guys. You're going to not put that there. Sorry. You're going to go percentages. You're going to go 0.02, 0.04, 0.06, and so on and so on and so on. And this will be relative frequency. Okay? So, your bar in this case would be 0.02, and there's 1. The next class would be 0.04. There's 2 of those. Okay? And actually, I'm not going to put that up there. Okay? 2% of the data, 4% of the data. Yeah, 2% of the data, I really should, I'm kind of messing this up, you guys, sorry. 2% of the data, 4% of the data, right there. Okay? If you compare the relative frequency histogram with just the regular frequency histogram, which you would have created here, the only thing that is different is how your y-axis is labeled. Your bars are still as high, they're still as proportionally high. It will still be the same shape of histogram, the same outliers, the same spread, the same, all that good stuff, okay? But the way you label your y-axis is the only thing that's different, okay? So that is it between a frequency histogram and a relative frequency histogram. Okay? I didn't graph all this, but if you finished your graph, you should realize that the heights are fairly symmetrically distributed. The average height is around 69 inches. There are very few people that are shorter than 66 inches or taller than 72 inches. These are just some general observations you could make by finishing out that histogram that I didn't finish out, but you guys can certainly go back and finish it out. That would be a good thing for you to do. Okay, so that is your lesson on histograms.